Hello Year 5, I'm back with another maths video this week, carrying on learning all about fractions. And you might notice I'm in a different classroom today. Guess which classroom I'm in today? Leave a comment on the blog to let us know. And I've got our learning question on the board and it says, can I convert from a mixed number to an improper fraction? Now yesterday we were converting from improper fractions to mixed numbers. Today we're just doing it the other way round, just to get a bit more practice and get us more familiar with these two new types of fractions. And I've got a question on the board for you. And first, who thinks they can tell me what this is as a mixed number? What is represented here and how would I write it as a mixed number? Remember, mixed numbers has that mixture of the number of wholes and the fraction left over. So looking at what I've got on the board, I can see I've got one whole bar, haven't I? So I've got one whole, so I can write the 1. And then what fraction is represented here with this one green part? And you should all be saying to me, it's half, Miss Smart, because if we look, it's half of the bar. So as a mixed number, I know that I've got 1½ represented here. Now what would that be as an improper fraction? Pause the video and have a go. So to go the other way to improper fractions, we need to identify the numerator and the denominator to write our improper fraction. So I'm going to start with the denominator, so the number of parts in a whole. And for that, I just need to look at one of my bars. And I can see that this bar is split into 2, so it's split into halves. And that tells me that our denominator is 2 for halves. I can do that, just put my denominator. And the numerator is the number of parts in the questions, or how many parts you've got. So I can see I've got 1, 2, 3. So this fraction, as an improper fraction, is 3 halves, otherwise known as 1½ And remember, improper fractions and mixed numbers are equivalent. They mean the same. They're just written in 2 different ways. Okay? Next question. Once again, I've got a mixed number here represented in bars, and I've written the mixed number for you here to get you started. I would like you to convert this into an improper fraction, remembering that that numerator is bigger than the denominator when we're looking at improper fractions. So pause the video and have a go, and then join back in when you're ready to hear the answer. So again, I'm going to start with my denominator to know the number of parts in one whole. So I'm going to look at one of my bars, and I can see I've got 1, 2, 3, 4. So this bar is split into quarters. So quarters is my denominator, so I put a 4 like this. Numerator is the number of parts in this question, so I need to count how many blue parts, how many blue sections I've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is my numerator. So 2¼ as an improper fraction is 9 quarters. Just like that. Easy peasy. Another one for you here, but I haven't given you the mixed number this time. So pause the video and write this picture, or this diagram, as a mixed number. What is shown here? And you should have had a time to think, and you should be able to see I've got 1, 2, 3 wholes. So I know there's a 3 in my mixed number, and the fraction that is left over is what we need to do now. So we need to count 1, 2, 3, 4, 5. 5 is the numerator because 5 are shaded. And we need to now work out the denominator. Remember what the denominator is? It's the total number in one whole. So that was, and then we got 1, 2, 3, 4, 5, 6, 7, 8. So 3 wholes, 1, 2, 3, and 5/8 is my fraction left over. So that is my mixed number, 3 and 5/8. Now, I want this as an improper fraction. So we know the denominator is 8 already, don't we? Because we worked out the number of parts in one whole for our mixed number. So that's going to stay the same. It's going to have the same denominator. But how many parts is in this question if we've got 3 wholes and 5 left over? So I could count all of these, and I might do that to check at the end, but we can use our times tables, can't we? Because if we know that 8 slices, 8 pieces is in one of these, we can count in our 8 times tables, can't we? And what we're doing is 8 times 3. Or I could show you this another way, of we could do 8 eighths, add 8 eighths, add 8 eighths. And what was left over? What fraction is left over in our 4th whole, if you like? And that was 5 eighths. And when we're adding fractions, if all the denominators are the same, we don't have to worry about them. So we just add the numerators like normal. So 8, 16, 24, I'm counting in my 8 times tables. Right, I've got 24. I'm going to hold that in my head, so I'm going to jot that there. I've got 24 in these 3 wholes, but I've got 5 left over. So 25, 26, 27, 28, 29. So the improper fraction is 29 eighths. Can you see why we might sometimes use mixed numbers? They are a little bit neater than having big numbers like this. But you come across both, which is why we learn how to convert between them to know what they mean. I've got another example here, but no picture this time, but that doesn't stop us, we can still work it out. So I've got 5 and 1/6, and I want to know what that is as an improper fraction. So what you're doing, when you've just got the mixed number like this, you're thinking you've got 5 wholes or 5 lots of 6, because 6 here tells us that that's how many parts are in a whole. So I can think about it. If I did 5 times 6, 5 times 6 is 30. And what I've done here is I've multiplied the whole by the denominator. Okay, so that's my first step. I can multiply the whole number, how many wholes I've got, by the denominator. What do you think I need to do next? Because I haven't finished looking at my mixed number. That's right, you need to add what's left over at the end. So let's get a different colour. Then you need to add whatever's up here, because that is 1/6. So 5 lots of 6ths will be 30, but we've got one more left over. So we need to do 30 add 1 equals 31. So who thinks they can put that as an improper fraction for me? And you should all be saying it's going to be 31/6. Can you see that the denominator has stayed the same from the mixed number? We've just worked out how many individual pieces that is for the improper fraction. Okay. Pause the video and have a go at this one on your own, and then check back in for the answer. So my mixed number is 2 4/5, just like we did last time. Or I'm going to show you 2 ways actually. So 2 4/5, we can think about it as 5/5 for one whole, add 5/5 for the second whole, plus the 4/5, which is the fraction left over. We can think about it like that, adding up our fractions, or we can do the multiplying of 2 times 5, which we know is 10, adding on what's left over, how many fifths or what fraction is left over, which would 10 add 4, which would give us 14. So let's do the adding the fractions first and check both of our answers. So remember, when the denominators are the same, we don't have to worry about them. We just add the numerators as we would normally. So 5 add 5 is 10. 10 add 4 is going to give you 14. And the denominator stays the same, because it was the same in all 3 fractions. So 14/5. Let's check down here. I got 2 times 5, which is 10. 10 add the 4 gave me 14. And I know my denominator already. So that gives us the same answer, okay? I hope that helps showing the different methods, and that you don't always need cubes or pictures to help you. It is just using that times table knowledge that is so important in your maths. Okay, have a go at your worksheet today. Let us know of any problems on the blog and we can try and help you. And see you tomorrow for Friday.